Okay, now we're going to talk a little bit about parallel lines, and this is now from section 5.8. So parallel lines always have the same slope. So what we want to be able to do eventually is, if I give you some equations, you need to be able to tell me, are they parallel? So let's look at it graphically first. Suppose I gave you a graph of 3 different lines. One of them here is line A, one of them here is line B, and one of them here is a horizontal line, line C. So you'd look at this and you go, Mr. Barkus, this is pretty obvious. A and B are obviously parallel lines, at least if you could draw well, they would be, because they will keep going in both directions and they'll never intersect each other. But what if you're like, but maybe it's not a very good drawing. How can you be absolutely certain that somewhere way in the future they don't cross? And the answer to that is, well, if they move in exactly the same way from one point to the next, then they will never cross each other. In other words, if the slopes are the same. So let's see what we have here. If I look at this point here, I will move down to right 3. So the slope of this line is -2, that's the down 2, over +3, that's the right 3. Line B, notice the same thing is happening. Down to right 3. So the slope of line B is also -2/3. This is really what tells me absolutely for certain that these two lines really are parallel. And you can see here that line C, do you remember, it actually has a slope that's 0. So whenever the slopes are the same, the lines are parallel. So what if I give you some equations? So let's give you an A, B, and a C. So if A is y equals 3x plus 5, and B is y equals -2x plus 7. Or let's make that plus 5, or plus 3. Make it a little bit trickier. Plus 3. And let's say that line C is y equals 6 plus 3x. So which lines are parallel? Well, they're the lines that have the same slope. So remember, slope we can find by looking at equations that are in y equals mx plus b form. And the m, the number in front of x, remember that's a number. So again, the slope is the number in front of x when you're in this form. So in this problem, my slope is 3. This problem, my slope is -2. This problem isn't in the right form, but I can fix that very easily. 3x plus 6. My slope is 3. A and B are parallel. How do I know that? The slopes are the same. So I could graph them to be absolutely certain, but they certainly are. Well, that problem was a little bit too easy. So let's give you a little bit harder one. So again, we're trying to decide if some equations are parallel or not. So let's suppose I give you y minus 2 equals -4 times x minus 1, and y equals -4x minus 2. Well, this equation here is already in y equals mx plus b form, so I can immediately identify the slope. So my slope is -4. I don't know what this line is, what its slope is, because it's not in the right form, so I need to make it so. So to do that, first thing I'm going to do is distribute this -4. So this will be y minus 2 equals -4 times x is -4x. -4 times -1 will make a +4. Remember, that's negative times negative. And now I need to add 2 to both sides. So I'll get y equals negative 4x plus 6. So what's my slope here? It's negative 4. Are the lines parallel? Yes. Same slope. If the slopes are any different numbers here, then they're not parallel. So if I gave you y equals negative 4x plus 6 and y minus 4x equals 6, I can see here that this m is negative 4. This m, it looks like it's negative 4, but notice it's in the wrong form. It's not an mx plus b. So I can't say, oh, the number in front of x, it's negative 4. No, only when you're in y equals mx plus b. You're not there. How do you make it so? Add 4x. These will eliminate. I'll get y equals not like terms. So I can add these in either order. So I'll put the 4x first and then the plus 6. It's the same thing as if I wrote 6 plus 4x, but this is a little cleaner. And now I can see that m is 4. Well, negative 4 is not the same number as positive 4. So are they parallel? No, not parallel.